All right. Hello, everyone. All right. So, week three, we're going to talk about graphing linear equation and then creating equation of a line. Okay. All right. So, let's start with one method of solving, not solving, graphing a linear equation, right? So, there are uh, several forms of a linear equation, right? So, you have the slope set form, which is y equal mx plus b, right? Plus b. You will graph this using the slope and the y-intercept, right? So this is different. When you have this format, usually use the slope, which is represented by m, and the y-intercept, which is represented by b. Okay? So you will use those two information to graph a linear equation. But what we have here is a standard form of an equation. So for example, ax plus by equal to c is a standard form. Okay, there is no slope that you can see here or that you can extract from. Well, you could extract it if you have a formula, but does not represent a slope, b does not represent a slope, nor c, and any of those a, b, and c letters represent a y-intercept. Okay, so I just don't want to confuse that with the first one. Now, the only way that we can not the only way, the best way to graph a linear equation in this format is by using what we call the x and y intercepts, right? And an intercept is basically when you have a linear equation, a linear line, right? So this is uh, a linear equation, right? So a normal one, right? And it's increasing, right? And then you have other ones. Let's maybe use another color here, right? May look like this. That's another linear equation. This one will be decreasing, and then you may have a straight line. They don't look straight, but you know that's another linear equation. That horizontal line will not look like this, nor like this, right? It will look like y equal to some value c, a real number, right? And then you will have a vertical line also. That's another type of line that you may see, and that vertical line will be x equal to some value c. Okay, it will look, these two horizontal and vertical line in terms of equation will look totally different from the straight slanted lines. Okay, all right, so now let's move on to um, graphing. Oops, so I just want to, okay, so here we want to graph this equation 10y minus 2x equal to -4 using the y-intercept, or the x-intercept, the x and y-intercept, I'm sorry. And the x-intercept is basically when the line crosses the x-intercept, which is this point here. And then the y-intercept will be when the line crosses the y-axis, right? So x-axis, the line crosses the x-axis, that's the x-intercept. And then when the line crosses the y-axis, this is the y-intercept. Okay, so y-intercept and then x-intercept. Beautiful. All right, so how do I do that? What type of knowledge do I have about those points? Well, it's easy. If any points on the line will be represented by a point like this. For example, for the y-intercept, it will automatically be, the x-coordinate is always 0, right? So it's 0. And then for some value of y, I'm just going to put y, right? So any point on the y-axis will be some value of 0 for the x-coordinate and y for the y-coordinate. X-intercept, it will be some value for x, so I'm just going to put x, and then for the value of y will always be 0. Okay, so the information that I have about the x-intercept and the y-intercept is that if I want to find the x-intercept, the y-coordinate is 0. So in my linear equation, I know that y will be equal to 0 if I'm looking for x. Okay, and if I'm looking for the y-intercept, the x-coordinate will be equal to 0. So that's all I have to do, set them up and find what the y is and x is. All right, so let's do that. All right, so now let's find the x-intercept, and that means that y equal to 0. Okay, so we have 10 times 0 minus 2x equal to negative 4. 10 times 0 is 0, so I'm left with negative 2x equal to negative 4, and then divide by negative 2, and then x equal to 2. That means that my x-intercept is going to be somewhere, not somewhere, it's going to be at 2, 0, the ordered pair 2, 0. Okay, now let's find the y-intercept. And the y-intercept is when x equal to 0. So let's plug in 0 for x. So we have 10y minus 2 times 0 equal to negative 4. Okay? Alright, so it's going to be negative 2 times 0 is 0. And we have 10y equal to negative 4. Divide by 10. And we get y is equal to negative 4 over 10. We simplify this, it should be 2 over 5, or negative 2 over 5. So therefore, my point for the y-intercept is going to be at 0, negative 2 over 5. We're going to represent this by a decimal number, right? So it's going to be negative 0.4. Let me see. It should be 2 divided by 5 is 0.4, so it's negative 0.4, 0, and then negative 0.4 approximately. Okay? All right, so we have our 2 points, and we know that our slanted line is going to go through those 2 points. So let's find them, right? So basically, you have a multiple choice here. So we know that the x-intercept is at 2, 0. That's what we have here. And we also know that the y-intercept is at 0, negative 2, 5th. And this is it. Okay? 2, 0, 0, negative 2, 5th. That's the line. You know, this is it. 2, 0 here. And here, negative 0.4 is between 0 and negative 1. And you can see it crosses that axis there. Okay? So that's how you use the y and the x-intercept in order to graph. Okay, so let's move on. Right? So you will do the same thing with those types. Alright, so so this one is a good example, right? So you have your so let's do this one, because you have to use your knowledge here. So here you have your coordinate graph, right? You have the x-axis and the y-axis, and here I have my horizontal line, right? And I did mention to you earlier that the horizontal line is represented by a function or an equation of y is equal to some value c. And the question is, what is that value c? Okay? Well, the value c is when the line crosses the y-axis, right? So if it crosses the y-axis, it crosses that point 0 and that value y. Okay? And because that horizontal line is below the x-axis, that y value is what? Negative. So here that value of c is going to be negative, y equal to some negative number that we don't know. But here they're giving us some options to guess what that value could be, or how that function is going to be, right? So first of all, it's not going to be any equation that has x, right? Because we just say it's going to be y equal to some. So these two are gone. Now we have to decide whether it's going to be one of those two. Obviously, I did tell you that the equation is going to be y equal to c. That's the standard form, but it could look like y minus c or y plus c equal to 0, and so on. But if I solve for y, right, the value on the right side has to be negative. So here, if I solve for y, I get y equal to 4, positive 4. So it's not going to be representative of this line here. So that cannot be this. So it has to be y plus 4. Why is it y plus 4? Because if I solve for y, I get y is equal to negative 4. And this y equal to negative 4 is representative of this horizontal line below the x-axis. Okay? All right. Moving on. And then here, you guessed it, right? Vertical line, it would be representative of x equal to c, right? Because it's vertical, x equal to c. So we know it's not going to be y minus 3 equal to 0, or y plus 3 equal to 0. It better be x equal to what? Is it going to be a negative number or positive number? So let's look. The vertical line here is on the left side of the y-axis. The y-axis represents 0, right? On the right side is the positive side, and on the left side is the negative side. So c has to be what? Negative. All right, so which one's going to present a negative number on the right side? It has to be x equal to, no, x plus 3 equal to 0, because it's going to turn out to be x equal to negative 3. Okay? All right, moving on. All right, so very interesting problem here. So how do I identify if the slope is positive, negative, 0, or undefined? Okay, so you have the 4 cases. I briefly touched on it earlier, but basically, if your slope m, right, is greater than 0, then your line, right, is going to look like this. Okay, so that's an increasing. Why is it that? Because, okay, if I'm starting from left to right, what's happening? I'm going from least to greatest, right, on the x-axis. On the negative side, the lowest point is going to be on the negative side for y, right? And then as I increase on the x-axis, what happened? The y value increases on the right, so it increases on the y value. So the line actually represents y. Okay, so if I say y is equal to mx plus b, right, the graph is going to represent whatever the value of mx plus b is. So if mx plus b is positive, then you know, my line is going to be on the positive side. If it's negative, then it's going to be on the negative side. Okay, so whatever you see on the graph is always representative of what y is. So you can see here y is on the negative side, and then it goes to the positive side. Okay, so this is how it should look like. Now, when m is less than 0, meaning it's negative, then my line is going to look like something like this. Okay, and you can see that on the negative side of on the x-axis is starting on the positive side, right? So it's positive here, right, all the way up to here, and then it's on the negative side. Don't forget, y is represented with the line, so it's positive, and then it goes to negative as x goes from negative infinity to infinity. So it will look like this. Okay? And then the other two cases is when m equal to 0. So when the slope equal to 0, it will be a horizontal line. Okay? So horizontal line, where it's when m is equal to 0. And we're going to talk about how to find the slope a little bit later, right? And then when m is undefined, that means it does not exist. Undefined means does not exist. Okay? And that's a vertical line. Okay? So how we answer this one, it is an increasing function or a positive slope, right? So, and it actually, if it's positive, it's increasing. If it's negative, it's decreasing line, and so on. All right. So you can look at this and you can say, all right, the y of the line is from positive to negative. So this is negative, right? Negative slope. Right? So horizontal line, I just talked about it. The slope is 0. And then here, a vertical line, as I mentioned, the slope is undefined. All right, so how do we find the slope of the line through the points, right? So let's look at the formula, right? So let's label those ordered pairs first, right? So basically x1, x2, and then, oh, I'm sorry, that's not x2, it's x1, y1, and then here is x2, y2, right? So 2 different points. All right, so what is the slope? The slope is a rate of change between 2 points, right? So we've seen what rates are, right? It's a change of units between one point to the other. And then we talked about increasing, decreasing, and also being horizontal, meaning there's no movement, or at the least, the rate is not changing. Okay. All right. So how do we find that? Well, there's a formula given to you, which is m is equal to y2 minus y1 over x2 minus x1. So if you follow this formula, which is really the the rise, right? So y2 minus y1 is called the rise, and we're going to talk about that a little bit later maybe. And then x2 minus x1 is called the run. Okay, so the rise is the difference between the two y coordinates, and then the run is the difference between the two x coordinates. Okay, so let's do that. So what is y2? y2 is 3 minus, that's part of the formula, y1 is 8, and then we have x2, that's 3 again, minus x1 is 1. So we get 3 minus 8, negative 5, over 3 minus 1, 2. So negative 5 over 2 is my slope. Well, what does that slope tell me about the line that goes through those 2 points? Well, if it's negative, we know that the line is what? Decreasing, right? That's the first thing that should pop up in your mind. When you know the sign of the slope, you should also determine how does the graph looks like. And it looks like this because of the negative. Okay, so let's do one more. Okay, it doesn't matter which one. Yeah, let's do this one. All right, so slope m is equal to, so let's label them. It doesn't matter which one you label as x1, y1, you get the same answer. All right, so y2, -6, minus y1. So y1 is -7, so it's minus from the formula, and -7 is the point y1, is the coordinate y1, over x2, 3, minus x1, 3 again. All right, so we have a problem, right? Because it's going to be -6 plus 7, right? The double negative becomes positive. So it's 1 over what's happening here, 0. If you use your calculator, 1 divided by 0 does not exist. It gives you an error. So therefore, this is undefined. Okay, please do not confuse 0 over 1 with these two. Those are not equal. Okay, this one is undefined. This one is equal to 0. Okay, so two different outcomes. So this is undefined. So what did we say about a slope being undefined? It is a vertical line, right? And a vertical line is going to cross what? 3, right? Because those are the numbers being repeated, right? It's always going to, it doesn't matter what point it's going to be. It's going to be crossing 3, -1, 3, 0, 3, 5, 3, 1 million. The x coordinate will always be the same for a vertical line. Okay, if you were to do this one here, just by looking at the points, now the values of y, the y coordinates are the same. So that means that they're going to cancel out when we're going to do the slope, right, on top, and the result is going to be 0. So that's how you can recognize whether a slope is going to be undefined or equal to 0 by looking at the x coordinates. So if the x coordinates are the same, exactly the same with the same sign, then it's undefined. If the y coordinate of the points are the same, then you can say the slope equal to 0 just by looking at it. Okay, now that we know a little bit about the slope, let's look at how to use the slope, and we're going to use the rise over the run to graph the next set of problem. So let me do this one here. Okay, so here we go. All right, so what do we have? All right, so in order for me to use the slope and a point to graph, then all I have to do is kind of look at what's given to me, right? So I have a point which is 4, -1, so I can plot that, right? So 4, -1, so we have 1, 2, 3, 4, and then go up 1 unit. That's my point 4, 1. Now I have to find a second point. But what do I know about the slope, right? Because I need to know, the slope gives me direction, right? So what is the direction of that slope? Well, the direction is given to me by the sign of the slope. M is what? Less than 0. And if M is less than 0, then it's a decreasing line, meaning that the line is going to look like this. Right? Those information were given to me. So it gives me a direction. So I know that my line is going to go like this. Right? So I can be, let me use, oops, that's not what I wanted to do. Let me see if I can move it a little bit. Right? So I know, I'm trying to line it up with this point here, but it's not working. Right? It's giving me, it's not lining up with, okay, never mind. But the line is going to look like this, right? And it's going to go through this point. Okay, so it's close enough, right? So it's going to go through this point. So my goal is to find, the other point that's going to line up with this this linear graph, right? So anyway, so let's try to do that using the slope. Okay, so the sign, the negative, tells me how the graph is going to look like. Now, I need to find the other point. How do I do that? Well, the slope here is regarded as being the rise over the run, right? And basically the 3/4 gives me the rise. And then the 3 gives me the rise, and the 4 gives me the run. So that's my proportion between those two things here. Okay, so what is okay, so how do I, so we did tell you that the rise is basically y2 minus y1, meaning that it is the vertical change, right, between 2 points. So if I'm at 4, -1, if I go up 3 units, then I will go up to my next points, my vertical change, right? To next point. So so if I go up 3 units, I'm sorry. So let me do that in red. So I get 1, 2, 3. So that's my vertical change here, or that's my rise. I could have gone down 3 units also, but so that's my rise here. But because my line, and let me go back to this shape here. Ugh. It's kind of going, okay. Right? Because my line is behaving that way, right? It has to behave that way. Then I have to go to the right, to the left. I have to go to the left to find my second point. I want to change the color of this because, okay. So I have to go to the right, right? Because if I go to the no, I have to go to the left, I'm sorry. Because if I go this way here to the right, then this point is going to line up with this other one, and you can see that if I draw a line between a point that is on the right here, it's going to create what? An increasing line, right? A positive line. So that's not what we want. So what we want is go to the right 4 units, find our points, and that point is going to create a decreasing line or a negative with a negative slope. Okay, that's very important. So if I were going down 3 units, 1, 2, 3, then I can go to the right about 4 units and find another point, and this point and the other point is going to create a decreasing line. Okay, I hope you understand this part, but that's very important. Okay, all right, so that's exactly what we're going to do here. Let me remove that. Here we go. All right, so my rise is 3, and I can go 4 units to the left. So 1, 2, 3, 4, right? And the second point is right here, and that's it. All I have to do now, I have 2 points at 4, -1. Oh my God. I put 4 plus 1. So let me put 4 plus 1 here because I don't want to do the whole thing over again. So let's imagine this is 4 plus 1. So that was my mistake. Okay. But the slope is still negative 3/4. Okay. So here, let's imagine that the point is at 4, positive 1. I mean, the mistake was supposed to be right here. But anyway, let's imagine that was 4 and 1. So all you have to do here is get this, and then that's all. That's all you need to do for this type of problem. Then you draw the line between those 2 points, and that is it. Okay, that's how you graph a linear equation using the slope and a point. Okay, so I apologize about the 4 and the 1. All right. All right, so now let's look at, the relationship between parallel line, perpendicular lines, or neither, right? All right, so here, if we're looking, so there's a line that goes through those 2 points, right? And here, there's a line going through those 2 points. Okay. All right. So if these 2 lines are parallel, the relationship should be m1. So parallel. The slope of the first equation. The first line is going to be 0. I'm sorry. That's not what I meant. That's equation number 1. This is equation number 2, or line number 1, line number 2, and then the slope 1 is going to be equal to the slope 2. Oh my God, I took like a full minute to say that those 2 slopes are equal to each other. Okay, it happens. So that's a relationship that you should have. So if I'm looking for the slope of these 2 points, of those 2 lines, it must be equal to each other. Now, if you want to establish perpendicular lines, the slope of these 2 should have the product m1 times m2. So when you find those 2 slope, when you multiply them, it should be equal to -1. Okay? If you don't like calculation, you can say, or m1 is negative, or no, not negative, opposite reciprocal of m2. And you're like, what does that mean? For example, if my slope is 2/3, if the first slope is 2/3, then m2 is opposite, meaning is negative, right? Because 2/3 is positive. And then it is also reciprocal, so it's going to be -3/2. That's what's going to establish the perpendicular lines if those 2 slope look like this. Okay? If it's a whole number, then it could be m1 is equal to -3, then m2 is positive, right? Plus, just to show that it's positive, and then the reciprocal of 3 is 1/3. Or you can just put 1/3. Okay? So that's how you can establish that. But first, we need to find the slope. So let's find the slope here. So m1, right? So you have 7 minus -5, 7 minus -5 over -1 minus -3, -1 minus 3, -1 minus 3. That's going to give me 12 over -4, which is -3. Okay? So that's my first slope. Then the second one, it will be 11 minus -13. So m2 is equal to 11 minus negative 13 over negative 2 minus 6. So negative 2 minus 6. So it's going to be 11 plus 13, 24 over negative 8. And that gives me negative 3. So they are exactly the same. So they are parallel. Right? M1 equal to M2. That's when we establish parallel. The other one is perpendicular. Right? That would fall into that category here. All right, so this one is parallel. I don't know which one's going to be perpendicular. I can go quickly, 19 and 20. Let's do a 20, right? Because it's going to end up being perpendicular, and you'll see, you know, what to expect. If it's neither, that means the two slopes have nothing in common from what we've seen, right? They don't fall into the category of parallel, and they don't go into the category of perpendicular. Okay, so that would be neither. Okay, so let's find M1, 7 minus 5, and then negative 4 minus negative 12. Negative 4 minus negative 12. That's going to be 2 over negative 4 plus 12. That's 8, which gives us 1/4. That's M1. Okay, so M2 should be equal to negative 2 minus 6, negative 2 minus 6 over 7 minus 5. So that's negative 8 over 2. That gives us negative 4. That's it, right? So opposite, is it opposite of 1/4? Yes, it's negative. What is reciprocal of 1/4? Yes, it's 4. 4 is the same thing as 4 over 1. So yeah. So it is perpendicular. Okay. All right. Now, all right. So here you have to look at this equation and determine whether it falls into any of those four categories of graphs, right? All right. So let's look at y equal to 3x minus 6. Well, 3x minus 6. What do we have here? We have the slope, and then we have the y-intercept. Okay. Well, the slope tells you the type of graph that we have, right? If it nm is greater than 0, so my line is going to look like this automatically. So you are done with these two here. Those are decreasing lines. So we're only dealing with these two. But we do have another piece of information, which is negative 6, right? That's my y-intercept. So at negative 6, where's that line where it crosses the y-axis on the negative side? Well, here it crosses on the positive side, so it cannot be negative 6, right? So this one is gone, and this is the one that crosses negative 6, it seems to me. And so A should be your answer. All right. All right, so now let's move to writing equation given a set of information, right? So in order to write an equation in whatever form, you need to be given at the least a slope and a point, or 2 points where you can create or you can find the slope given those 2 points. Okay. All right. So here we want to write an equation in slope set form, meaning y equal mx plus b, right? And so how do I find that? Giving this slope. Well, we know the slope is going to go right here. So we are halfway done. But what is b? Is b given to us here? No. So don't you dare putting the -3 where b is. Why? Because this point right here is not a y-intercept. So this is not a y-intercept. How do I recognize it's not a y-intercept? Because here it is not a 0 at 3. Okay? This is not a 0. A y-intercept will look like 0, -3. If we add a 0 here, then you can surely put the -3 here for b, and then you will be done. But that's not the case. Okay, so how do I find what b is equal to? Well, it's easy. Because the slope, the slope is the slope. But the point here is really representative of all the x and y coordinate, right? So 3, -3 represent what? X and y. And do we have those variables in that equation? Yes. So because we know what x is, we know the slope is, and we know what the y is, everything is given to us. So therefore, I can plug in those values for x and y and m, which is the slope, and then I can solve for b. Okay? So that would be the kind of the quickest way for this one. So let's do that. Y is equal to -3, m is equal to -4, and x is equal to +3, and then b, we don't know what it is. So we have -3 equal to -12 plus b. Now solve for b. So all we have to do is add 12. So it's going to be -3 plus 12 equal to b. And that's 9. So b is equal to 9. So we have b equal to 9, m equal to -4. So now my equation is going to be y equal to -4x plus 9. That's it. That's my slope set form. I just kind of plugged in all the information that I had to find. That's it. That's how you deal with this equation here. Okay. This one should be easy, right? Because now you have the slope. Perfect. And now they're giving you the 0.05. What is 0.5? You have to recognize that 0.5 is what? A y-intercept. So all you have to do here is say, okay, y equal to 2/3, that's m, x, and then the 5 here is what b is, right? Plus 5. And you are done. Only in this condition where the x coordinate is 0 that you can put 5 here, or the value that is right here. Okay? If there's no 0, then you have to do it just like I did previously. Here we go. All right. This one is a tricky one. It might be. Not really. This one is not that tricky. But there's a way that you can just do it mentally, right? Because you are given a very important information. And that important information is what? Slope is equal to 0. Okay, we discussed that. The first thing that you should have to think when they say the slope equal to 0 means that, oh, it is a horizontal line. Okay, and the horizontal line looks like y equal to c. Okay, and now you have to say, oh, y equal to c, what does that mean? What does a c means? Well, it means that when my line crosses what? The y-axis, it has to cross a y value. And the y value here is -9. So therefore, my equation is going to look like y equal to -9. You're not even interested in the 4. Because a horizontal line always going to have what? A y coordinate that is equal to -9, right? It could be 1, -9, 0, -9. It doesn't matter. It's always going to be -9. So that's one way of doing it. For this one, you can actually do it like this, right? You can say, okay, well, my slope is 0, and and you find your equation. You can do it like that too. But anyway, let's look at another one. This one is also important because here you cannot make any type of calculation because the slope does not exist, right? It's undefined slope. So automatically you say to yourself, if it's an undefined slope, you have no choice, you have to remember it. It is a vertical line, right? And the vertical line means that what? It's going to cross what? The x-axis. And my equation is going to be x equal to c, right? So what is c? If it crosses the x-axis, it better cross what? An x value. And because the line goes through the point 8 and -4, it's going to better cross what? X, which is 8 here. So my equation is going to be what? X equal to +8. Okay? All right. Let's move on to the next set. All right, so here we want to write the slope itself, write the equation slope set form. But now the line goes through 2 points. We are not giving it a slope anymore. We are given 2 points. So let's see how we can use this. I'm going to introduce another formula as well, which is the point slope form. Okay, but first we need to find the slope, right? Because we need the slope. So it's going to be m equal to -6 minus -2 over -1 minus -3. Okay, so -6 plus 2 is -4, and -1 plus 3 is +2. And we get a slope of -2. Here we go. Now, I want to introduce another equation, which is called the point slope form. And it goes as follows. Y, so point slope form, is y minus y1 equal to m times x minus x1. Okay? And you can use that to find a slope set form or a standard form. But anyway, so we're going to use it. So obviously you have to have a slope and a point given to you, and we have that. So let's plug in. And here we're going to use, let's say, -1, -6. You can use -3, -2. If you want to, you get the same answer at the end. All right, so you have y minus y1. So y minus -6 equal to m, which is -2, times x minus x1, -1. Simplify this. Y plus 6 equal to, this is x plus 1, right? So let me put x plus 1 here. And we put -2 times x is -2x. And -2 times +1 is -2. Okay, so we're almost done because we almost have it in slope set form, which is y equal to mx plus b. Right? So all I have to do here is solve for y. Move that +6 to the right side, and I should get y equal to -2x minus 2 minus 6. These two are combined, and I get y is equal to negative 2x minus 8. And that's my slope-intercept form. Okay? So that's it for that. Okay? So I introduce a new equation, a new way of doing, finding an equation. All right, so let's move on. So you can do the same thing with these two. Well, the slope here is going to be undefined because you have 10 and 10. So you have to find, it's going to be x equal to 10, right? So easy. Here, again, if you're looking at the point, what is the slope? Well, the y coordinates are the same, so the slope is going to be what? 0. Okay? My equation is going to be what? A horizontal line, y equal to 1. Okay? Get used to that. All right, so we did a problem like this already. So let me try to find another one. There is one that I wanted to do. I may have to make it up. Yeah. So I don't see it here. Yeah. So let me try to make up one one equation. Yeah. All right. So I want to do a problem that is similar to this, but let me just kind of make up some stuff here. Okay. Okay, so it's a problem that you're going to see. All right, so so here I want to write. So I'm just making up stuff. Write an equation that passes through the point let's say -2, 5, and is perpendicular to the line equation y. Well, let me put it in standard form. I'm going to do the hard part. 2x plus 3y equal to -6. Right? So you might see something like this. It's a very good problem to go through. All right. So, and that's the last problem. Okay. So, okay. So we have actually two line equation involved, right? So basically, we have a line that goes through the point -2, 5, right? But so line 1, that's the information we have. Line 1 goes through negative 2, 5. But what's missing? The slope. So M1, we are missing this. We need that. But it tells you that line 2 is perpendicular, that's perpendicular sign, to line 1. Okay? And line 2 is 2x plus 3y equal to negative 6. What does that mean for me? Well, it means that I know the relationship between those two lines, right? Because I know that the M2, the slope of M2 of this is what? Is opposite, is opposite reciprocal to M1. So the only way I can find M1 here, because that's the equation that I need, is to find M2 first, based on this equation. Well, I can find M2 here. It is in standard form, but if I solve, find M2 by solving for y. Right? So let me solve for y here. So it's going to be 2x plus 3y equal to negative 6. Solve for y, meaning that it's going to be 3y equal to negative 2x minus 6. Okay? Divide by 3, and I'm going to divide everything by 3. And I do it like, by terms. And I get y is equal to negative 2/3 x minus 2. Beautiful. All I need is this, because this is what? M2. I don't need this. Now, let's figure out M1, because that's what I need, right? So M1 should be what? The opposite reciprocal of M2. So what is the opposite of negative 2/3? Is positive. And what is the reciprocal of 2/3? Is 3/2. Beautiful. M1 is equal to 3/2. Okay, mission accomplished. Now I have a point and a slope for line 1. And that's what I'm interested in, right? I need to write an equation that passes through the point negative 2 and 5 and then has a slope of 3/2. Now I can do that. Now, but I want the equation, so I'm making up as I go, because you're going to see a problem like this. Now I want the equation to be written in standard form. And that's what we're going to do. Standard form means that I want it as ax plus by equal to c. Okay, so let's start with the point slope form. Y minus y1 equal to m, in this case m1, times x minus x1. Okay, so that's what we want to do. So the point that was given was what? Negative 2 and 5, right? So negative 2 and 5 will be x1, y1. So y minus y1. So let me put negative 2 and 5, and then m1 3/2. Okay, so y minus y1, y minus 5 equal to m1 3/2 times x minus x1 minus 2. Simplify this, you get y minus 5 equal to 3/2 x. Let's not forget this is a plus, so 3/2 times That's 6 over 2 or 3. That's positive 3. Okay? Now, the next step will be to put it in standard form. Let's not forget that the standard form is this here. So now we're not solving for y and putting y equal to mx plus b. That's not what we're doing. What we're trying to do here is to put it that the x term and the y term on the left side and some constant terms on the right side. So that means I want to combine this one and this one on the same side, and then these two on the right side. So let's do that. So here I'm going to have y minus 3 over 2x, right? So I'm moving this to the left side and this to the right side, and I should get 5 plus 3. And then I get y minus 3 over 2x equal to positive 8. Okay, so it kind of looked like, you know, the standard form, correct? But not totally, because there is a rule for the standard form, and the rule is a, b, and c must be what? Integers. So integers are what? -1, -2, 1, 4, 5. There is no fractions in for integers. And what do we have here? We have a fraction, which is 3 over 2. So we cannot have that. So we need to find an equivalent equation by using the LCD. So what we're going to do, we're going to multiply all the terms by the LCD. So the LCD is equal to 2. So therefore, we need to multiply the whole equation by 2. And what do we get? We get 2 times y, 2y, minus 2 times 3, 6. 6 divided by 2 is 3. So 3x equal to 2 times 8. Even that the one after the equal sign must be multiplied by 2. So 16. And that's it. That's your answer. Sometimes, you know, the x term is required to be the first term. Usually for standard form, the first term is always positive. That's why I put 2y. I left 2y as the first term. But if you want the x term to be the first term, you need to multiply the whole thing by -1, right? And it becomes, so if you multiply by -1, you get -2y plus 3x equal to -16. And then you swap those two, and you get 3x minus 2y equal to -16. And you can represent your answer in standard form like this or like this. Those are the two options. Okay? So that's it for this week 3 presentation.